Hello class, what I have in my hand is a Teal Dennis tube. Okay, it's a Teal Dennis tube, and you can see that it has an oil in it. Now this tube has an elbow and an elbow and a tube, and in this tube is an oil. This oil is a high boiling point liquid. It's a high boiling liquid known as silicon oil. It boils at about 300 degrees, so it's able to serve as a heat storage liquid. It can store a lot of heat used to determine the melting point of a particular substance. So what we're going to be doing today is we're going to be determining the melting point of a solid. Now this solid has been placed in a capillary tube, just like we did for the melter block. We have placed the solid in a capillary tube just like we did for the melter block. So what I'm going to do is I'm going to attach this capillary tube with the solid. Okay, you can see that the solid is about 1/8 of an inch. The height of the solid is about 1/8 of an inch. I'm going to attach this to a thermometer. See, I'm going to attach it to a thermometer. I'm going to attach it to the thermometer using some rubber bands. Now, so this is what the rubber bands look like. See, this is what the rubber bands look like. All right, this is what the rubber band looks like. You can see it. See, that's what the rubber band looks like. So we're going to attach this capillary tube to the thermometer with the aid of 2 rubber bands. See, we're going to use 2 rubber bands. Okay. The reason for using 2 rubber bands is so that the capillary tube is very secure. Okay. Now, what you observe is that the solid is just next to the thermometer, the bulb of the thermometer. You can see that. All right. And we have a stopper here, and the purpose of this stopper is to ensure that you can hang this thermometer in the oil. Okay, so we're going to hang this thermometer in the oil carefully. Okay, I'm going to hang it in the oil. Right, and then we're going to clamp it here. Ideally, you want this hose, the thermometer and the sample tube to be like halfway between this height, that is the upper end of the elbow and the lower end of the elbow. You want it to be in between. Okay, and then notice that I have a small flame here. Okay, and you can see we see the elbow. You're now going to begin to hit the elbow. See, you're going to begin to hit the elbow. All right, and as you hit the elbow, what's going to happen is that the temperature of the thermometer will begin to rise. The temperature of the thermometer will begin to rise. Okay, now the temperature of the thermometer is about 47 degrees. Okay, so what you want is for the temperature to rise. Once the temperature starts rising, okay, you want to take away the heat source. At this point, the temperature is not rising, so we just keep heating. Now you got to heat slowly because it takes time for the heat to travel from the elbow to this tube. It takes time. You see, it takes time for the heat to travel, and so you have to give the heat enough time to travel so that you can have what we call thermal equilibration, or a uniform distribution of heat. Okay, so like I told you, once the temperature of the thermometer starts to rise, that's the point where you have to take away the heat source. You have to take away the heat source. If you don't take away the heat source, it's going to rise too quickly, and if it rises too quickly, it's going to overshoot the melting point of the sample too quickly, and what's going to happen is you're going to get an incorrect reading. Remember, it takes time for the heat to travel throughout the entire liquid. Okay, And so you want to make sure that the temperature around this elbow and the temperature where the sample is the same. Okay. You also want to make sure that the temperature that the bulb of the thermometer is experiencing is the same thing as the temperature that the sample is experiencing. And so you keep looking at the temperature of the thermometer. Okay, right now we're at about 64. You keep heating it. See that? We're at 65 now. Okay. And you can see that the sample is still a solid. You see? So while you're heating, you're also checking the temperature of the thermometer as well as the solid. You want to make sure the solid has not started melting, because once the solid starts melting, you want to observe the start temperature. Okay, and then when the solid has completely melted, you want to also record the stop temperature. Remember, melting point is a range. It's a range. So right now we're about 82, 83. Okay, and we're at 84 now. We're at 84, and at 84 I can see that the sample has started melting. See, it started melting. It started melting. Started melting. And right now we're at 89, 90, 91, 92, 92.5, and the sample is completely melted. So you can see that the sample started melting for me at 84 and stopped melting at 92. So for me, I will record the melting point as 84.0 to 92, okay, which is pretty close to what we observed with the metal block. Okay, so basically that's how we do determine the melting point using the Thiel Dennis tube. I hope this helps. I'll be in lab to answer more questions. Bye for now.